Okay, welcome back to Math 130. We're going to be talking about multiplication and division of radicals. Part B. All right, now we're going to put that multiplication of a binomial times a binomial to use. Example 7. 1 over 3 plus the square root of 2. Now the problem with this is, of course, the square root of 2 in the denominator. We want to get the radicals out of there. We want to rationalize that denominator. But to do that, let me show you what will not work. Okay, so it's in red as a warning. Don't try this at home. Okay, when you see that radical 2, you may be tempted to just multiply by the square root of 2 over the square root of 2. However, if you do that, doesn't matter what's happening in the numerator, what will happen in the denominator is that this square root of 2 will be distributed to both terms in the binomial. So you'll get 3 square root of 2 plus square root of 2 squared is 2, but you still have a radical in the denominator. So this will not work. Instead, let's take a look at the denominator itself. 3 plus the square root of 2. And now I'd like to remind you of a pattern that we've seen before. We've worked with this pattern of a binomial multiplied by a binomial with the same terms, but instead of addition, subtraction inside. And when we multiplied this, distributing everything in the first binomial to everything in the second, we get the difference between two squares because the middle terms add to be 0. So let's see if we can find the same pattern using the binomial denominator that I wrote above. So if we have this 3 plus the square root of 2, if we follow the pattern and multiply that by 3 minus the square root of 2, and once again we distribute, 3 times 3 is 9, 3 times the negative square root of 2 is negative 3 square root of 2, and square root of 2 positive times positive 3 gives us a positive 3 square root of 2, and then we have a negative square root of 2 squared. And look at that. The middle terms add to be 0. So we have 9, and then minus the square root of 2 squared is 2, or it equals 7. So if we apply that technique over to our original problem, where that 3 plus the square root of 2 is in the denominator, we can rationalize the denominator. Look, no radicals in that 7. So let's multiply by 3 minus the square root of 2, but this is a fraction. We have to multiply by 1. We don't want to change the value of our original fraction. We're multiplying by 1 in the form of 3 minus the square root of 2 over 3 minus the square root of 2. Okay, so in the numerator, we will have 3 minus the square root of 2. But in the denominator, well, we already did the work over here. We'll just have 7. No further reduction needed. Okay, let's move on to example 8. Okay, example 8 is 3 minus 2 square root of 3 over 2 minus 7 square root of 3. Okay, we're going to apply the same technique we just worked with. I'm going to pull that denominator out to the side so I can rationalize it. Okay, or at least do the multiplication I'm going to need to rationalize the denominator when I move back over there. Okay, I'm going to write the same first term, the same second term, but I am going to change the operation in the middle. Here I've gone from subtraction to addition. In the previous problem, if you look back, you'll see I went from addition here to subtraction in the second binomial over here. All right, so 2 times 2 is 4. 2 times 7 square root of 3 is 14 square root of 3. Negative 7 square root of 3 times 2 is negative 14 square root of 3. And negative 7 square root of 3 times positive 7 square root of 3 will give us negative 7 square root of 3 squared. So we have 4. The middle terms add to be 0. And we have 4 minus 7 squared is 49. And square root of 3 squared is 3. So we have 4 minus, what is that, 27, carry 2, 147, which going further is negative 143. And I did that work out to the side, so I didn't have to recopy everything as I went along. Just remember that my calculation over here is what we will get when we go back to the original and what we'll get in the denominator. And we multiply this denominator by 2 plus 7 square root of 3 in the denominator, but in the numerator also 2 plus 7 square root of 3. So we still have some work to do on top there. We're going to have a binomial times a binomial on the top as well. Okay, so distributing on the top here as we need to. Okay, 3 times 2 is 6. 3 times 7 square root of 3 is positive 21 square root of 3. Negative 2 square root of 3 times 2 is negative 4 square root of 3. And negative 2 square root of 3 times 7 square root of 3 will give us a negative 14. And the square root of 3 times the square root of 3 is 3. And that's all over. Oh, we already did the work, so we can just pull it over here. Negative 143. So let's do some more work in the numerator. 6, let's see, 21 minus 4 is a positive 17 square root of 3. And 3 times 14 will give us 12, 42. And that is a negative 42, because it was negative 14 times 3. And that's over negative 143. Each line is equal to the one previous. And we have 6 minus 42, or negative 36, plus 17 square root of 3 over negative 143. And that's it. That's as far as we can take it. It's as simplified as it's going to get. But notice we have no radicals in the denominator. We have rationalized it. Okay, one last example. As a reminder of what the previous example looked like, I've rewritten the denominator up here at the top, but I'm actually going to do the next problem, problem 9, over here. This time, we're going to have a binomial in the denominator, but the entire binomial is underneath the radical. So since the entire binomial is underneath a radical, we could just do a substitution. Anytime something looks a little bit complicated, you can pull out a substitution. Let's put that binomial, x plus y, and let's let it equal, z. Okay, every place I see x plus y, I'm going to write z. So working over here, 4x, okay, that's not x plus y, I don't have to put z there, over square root of z. All right, so if that were your problem, 4x over the square root of z, what would you multiply by to rationalize the denominator? Yes, you would multiply by the square root of z in the numerator and the denominator, and you'd have 4x square root of z on top, and on the bottom, squaring the square root of z, you would just have z. Well, the exact same technique is going to work in our original problem. Okay. I just needed to make that a little smaller and get it out of the way. So we're going to do a similar thing here. Our denominator, all of it is under one radical, and it is a square root. So I'm just going to multiply by that same square root. Okay. And when I do that, on top I'm going to have 4x times the square root of x plus y over the square root of x plus y squared will be x plus y. Everything on top is multiplied by itself, except for that x plus y, which is all under the radical. So we have 4 times x times everything under that radical, and we're done. And we're done with this video as well. I'll see you in Blackboard Collaborate.